As the gas cutting machine applies a controlled flame, it melts the metal at the cutting point. This process is essential for shaping the steel plates into manageable pieces, which will then be further processed in the factory. In this stage, the gas cutting machine begins its process, using intense heat to cut through the thick, rusted steel plates. The precision of the cut ensures that the plate can be properly processed and repurposed for new uses. After the thick steel plates are cut into sections, the pieces are carefully transferred onto a moving conveyor belt. This ensures a smooth transition to the next stage in the processing line, where the sections will be further handled. Once the steel plates are cut into sections, they fall onto the conveyor belt, which carries them along the factory floor. This step is crucial in organizing the sections for further processing, ensuring efficiency and accuracy. As the cut steel pieces move along the conveyor belt, they are guided towards the scrap crusher machine. The conveyor system plays a crucial role in transporting the sections, ensuring a seamless process flow as the metal heads toward the crusher for further processing. The conveyor belt ensures that the steel pieces are carefully transported to the scrap crusher machine. Once the sections reach the machine, they are ready for crushing and further breakdown into smaller pieces for recycling. Once the cut steel sections reach the heavy crusher machine, the machine uses intense pressure to break the metal down into smaller pieces. This process ensures that the steel is prepared for further recycling and reprocessing in the factory. The heavy crusher applies immense pressure to reduce the steel to smaller fragments. This is an essential part of the recycling process, breaking down large sections into manageable sizes for future use. As the metal moves along the conveyor, the magnetic separator pulls any ferrous materials away, ensuring that only the clean, non-contaminated steel proceeds to the next stage of the process. The magnetic separator is a crucial step in the recycling process. It uses powerful magnets to remove unwanted metals from the material, ensuring that only the desired steel pieces continue forward for further processing. After the magnetic separator removes the unwanted metals, the clean steel pieces move onto the sorting line. Here, workers manually inspect and sort the material based on specific criteria, ensuring that only the highest quality steel moves forward. Once the steel pieces have been cleared of contaminants, they move along the sorting line, where they are carefully inspected and sorted by size and quality. This step ensures that only the best material moves forward in the process. With the hydraulic press in action, the steel is compressed under tremendous force, reshaping it into the desired form. This process helps to prepare the material for the next phase of its journey through the factory. The hydraulic press uses immense pressure to compress the steel, reducing its size and shaping it for further processing. This process is essential for ensuring that the material is compacted and ready for the next stages of production. In this stage of the process, the machinery works under immense pressure, causing oil to drip and smoke to rise. This is a natural result of the high-intensity operations, adding to the industrial feel of the factory environment. As the press operates under extreme force, oil seeps from the machine and smoke fills the air. This adds to the industrial atmosphere, where heavy machinery and intense pressure are part of the daily operations in the factory. The small steel chunks are carefully dropped into the furnace hopper, where they will be melted down and reprocessed. This step is essential for preparing the steel for the next phase of production. As the steel chunks fall into the furnace hopper, they are prepared for the next stage: melting and reprocessing. This is a key step in recycling and transforming the steel for future use. As the steel chunks are moved along the conveyor, they are guided directly into the furnace inlet, where they will be melted down. The conveyor ensures a seamless flow of material to the furnace, making the process efficient and controlled. The massive furnace door opens to reveal the high-temperature environment inside. This is where the steel chunks, having been carefully moved along the conveyor, will enter to be melted down for further reprocessing. As the furnace door opens, the heat becomes palpable, and the steel chunks are ready to be placed inside. This step begins the process of melting the material, preparing it for the next stage of production. As the furnace door opens, the heat becomes palpable, and the steel chunks are ready to be placed inside. This step begins the process of melting the material, preparing it for the next stage of production. As the steel chunks enter the furnace, they are exposed to extreme heat, which melts the metal down, preparing it for further processing. This is a crucial step in recycling and reusing steel materials for future production. The steel enters the furnace, where the intense heat begins to melt it down. This step is vital for transforming the steel into a reusable form, ready for the next stages of production. The steel enters the furnace, where the intense heat begins to melt it down. This step is vital for transforming the steel into a reusable form, ready for the next stages of production. As the steel chunks enter the furnace, they are immediately surrounded by the intense red and orange molten metal. The extreme heat causes the steel to melt down, preparing it for further reprocessing. Inside the furnace, the steel is surrounded by intense molten metal, glowing red and orange. This high temperature is what allows the steel to melt down and be transformed into a usable form for the next stage of production. Inside the furnace, the steel begins to melt under the intense heat. The molten metal glows brightly, slowly consuming the steel and transforming it into a liquid form, ready for the next stage of reprocessing. As the steel reaches extreme temperatures inside the furnace, it begins to melt, turning into a molten liquid. This transformation is crucial for the next phase of the production process, where the material will be reshaped and reformed. Once the steel has melted, the molten metal is carefully poured into a ladle. This step ensures that the metal is safely transferred for further shaping and processing, as the ladle holds the liquid steel for the next stages of production. The molten metal flows from the furnace into the ladle, where it will be stored temporarily before being moved to the next stage. This step requires careful handling to ensure the molten steel remains at the right temperature for further processing. Once the molten steel is in the ladle, a crane carefully lifts and moves it to the next stage of production. The steel is transferred safely, maintaining its intense heat and molten state, ready for further shaping. As the ladle is lifted by the crane, the liquid steel is carefully moved, ensuring it remains at the right temperature. This transfer is a critical part of the process, preparing the molten steel for its next stage of production. The molten steel is poured from the ladle into the mold section, where it takes shape. This is a critical stage in the process, as the steel begins to cool and harden, forming the desired sections for future use. As the molten steel enters the mold section, it begins to form specific shapes. This step is essential for controlling the size and structure of the steel products, ensuring that they are ready for the next stage of processing. Once the molten steel has been poured and begins to cool in the molds, the casting molds are carefully arranged in a line. This allows for efficient movement and processing of each mold as the steel continues to solidify. The casting molds are arranged in a straight line to facilitate the efficient movement and processing of the steel. This organized system ensures that each mold is ready for the next steps, allowing for smooth operations on the factory floor. The cooling water spray system is activated to rapidly cool the steel within the molds. This process ensures that the steel solidifies at the correct rate, preventing any defects and ensuring high-quality production. As the cooling water sprays over the steel molds, it rapidly lowers the temperature, helping the metal solidify evenly and efficiently. This is a critical step in controlling the cooling process and ensuring that the steel is ready for the next phase. Once the cooling process is complete, the solid steel rods are carefully removed from the molds. This step marks the transition from molten metal to solid steel, preparing it for further shaping and processing. After the steel rods have cooled in the molds, they are carefully extracted. This process requires precision, as the rods must remain intact and free from defects as they are removed from the mold. Once the steel rods have cooled and solidified, they are transported to the rolling mill machine. Here, the rods are passed through heavy rollers that will shape and size them according to the production requirements. As the steel rods enter the rolling mill, they are squeezed and shaped under immense pressure. The rollers compress and elongate the rods, transforming them into the desired form for further use. The rolling machine shapes the steel by passing it through powerful rotating rollers. These rollers apply immense pressure, transforming the solid metal into the required shape and size for the next stage of production. Inside the rolling machine, the steel is shaped by applying controlled pressure through rotating rollers. This process ensures the steel is reshaped to the exact specifications needed for future applications. As the steel rods move through the rolling mill, they are gradually stretched and thinned into a long wire. This transformation is a key step in shaping the steel for its intended use, whether for construction, manufacturing, or other applications. The steel rods are carefully pulled through the machine's rollers, which elongate and shape the metal into a fine wire. This process requires precise control to maintain the quality and consistency of the wire. The steel rods are carefully pulled through the machine's rollers, which elongate and shape the metal into a fine wire. This process requires precise control to maintain the quality and consistency of the wire. The cutting machine is designed to slice the steel rods into smaller, manageable pieces. This step ensures that the steel is ready for the next phase of processing or for packaging, depending on its intended use. Once the steel has been shaped and cut into bolt blanks, they are placed on the conveyor belt for further processing. The conveyor ensures the pieces move efficiently to the next stage, where they will be formed into finished bolts. The bolt blanks move steadily along the conveyor belt, ready for the next phase in the production line. This step ensures the blanks are prepared and sorted before being formed into the final bolts. The threading machine shapes the bolts by creating grooves along their surface. These grooves, or threads, are essential for the bolts to fit securely into corresponding nuts, ensuring they function properly in the final product. As the bolts pass through the threading machine, precise grooves are cut into the metal. This step is vital for creating the correct threads, allowing the bolts to be securely fastened during assembly. At high speeds, the threading machine's tools rotate, carving clean and precise grooves into each bolt. This high-speed operation ensures that the threading process is both efficient and precise, reducing production time while maintaining quality. The high-speed rotation of the threading machine is essential for creating precise grooves on the bolts. The machine's rapid movement allows for efficient and accurate threading, ensuring the bolts meet production standards. The oil lubrication system is crucial for maintaining the threading machine's performance. It ensures that the moving parts stay lubricated, reducing friction and preventing wear and tear, which helps the machine run smoothly at high speeds. As the oil lubrication system is activated, it ensures that the cutting tools stay well oiled, preventing excess heat and allowing for a smoother cutting process. This step is vital to keep the machine in optimal condition and ensure precision in the threading operation. Workers perform thorough quality checks on each bolt to ensure they meet production standards. Defective bolts are quickly identified and separated into a designated bin to prevent them from moving forward in the production process. Each bolt is meticulously checked for defects. Any issues are immediately detected, and defective bolts are set aside in a separate bin to ensure the final product is of the highest quality. After the bolts are completed, they move to the polishing machine, where the surface is smoothed and polished to ensure a shiny, flawless finish. This step adds the final touch to the bolts, preparing them for shipment or further use. The polishing machine ensures that every bolt is given a smooth, high-quality finish. The process removes any imperfections and enhances the bolt's appearance, making it ready for its final destination. After the bolts are polished, they are placed on the drying conveyor, where air blowers or drying units ensure they are completely dry. This step is crucial to remove any remaining moisture before the bolts move on to the next stage. As the shiny bolts travel down the drying conveyor, air jets or heat elements ensure that they are fully dried. This ensures that the bolts are in perfect condition before being packaged or shipped. The packing machine fills each bag with bolts, ensuring consistency and accuracy in each package. The bags are then sealed and ready for shipment, ensuring the bolts are securely packed for delivery. Once the bolts are fully processed, they move to the packing machine. The machine carefully fills each bag with the required number of bolts, ensuring that every package is filled accurately and sealed for shipment. The packing machine fills each bag with bolts, ensuring consistency and accuracy in each package. The bags are then sealed and ready for shipment, ensuring the bolts are securely packed for delivery. As millions of finished bolts move along the conveyor, the final steps of production are complete. The bolts are now sorted and ready for packaging, ensuring a seamless flow from production to distribution. The final stage of production sees millions of finished bolts moving efficiently along the conveyor. These bolts are now fully processed, inspected, and ready for shipment to their final destination.